Once again, my name is Mr. Anthony Wyckoff. I'm one of the directors and owners of Embrace Student Educational Services. We work with schools as well as various programs all throughout the country. Como League and Catholics, Bucks County Technical High School, as well as the 21st Century Grant. A number of others are actually affiliated with our program, as is a number of other organizations. Um, I previously, before becoming the owner and founding Embrace, I've been a teacher in education for a number of years. Probably one of the more notable things that I've done is I was actually a former faculty liaison working out at Stanford University. So today, if you guys have any general questions regarding the college admissions, right, and just in general of like what you're really working towards, how all of this is going to be utilized, you guys are more than welcome to ask, and I will save about, I would say, 5 minutes at the end. We'll call it the college admissions tip of the day, if you will. So that way you guys are in a little bit of a better spot to make it easier for you. Okay. Um, you see screen is shared, and we're going to get ready to go through a number of different things. One of the suggestions I will make, and I've already posted this information in the chat, but one of the suggestions I will generally make is that take screenshots, guys. Yeah, I'm going to send everything to you via email, but take screenshots so that way you guys have the ability to like utilize this information. The biggest thing I'm going to teach you how to do today, and Miss Caitlin already did a fabulous job of sort of walking you through just the general foundations. Granted, in the beginning, it is always very, I would say, detail heavy of kind of what to expect when you're taking the SAT. Moving forward, we're going to get a lot more of the strategies and the practice problems. But like any game, when before you play, you sort of have to sit there and read the instructions for for a little bit, right? I mean, it helps to know what the instructions are, so that way you have a better understanding of really how to play the game. And that's what we want to do. We want to put you guys in a position of success. Okay. And because of the fact that she does such a good job of sort of walking you guys of, hey, what to expect, and yes, she will go into detail and cover essentially the practice problems and the reading strategies and the timing and all that other stuff, right? We're here for you. I'm actually going to spend a little bit more time jumping right into the content, right, in terms of the test. So number one thing that I will tell you, and let me actually post this real fast for you guys who are joining us or sort of circling back. I see there's a few individuals that haven't logged back on, but just in terms of general housekeeping, I'm going to take this hyperlink and I'm going to post it in the chat for you guys. So that way, whatever we're working off of, you always have the ability to see it. So there it is. There's the hyperlink. I will also tell you that, yes, and Ms. Caitlin was mentioning this previously, that you can use this book, right? You can essentially order it from Amazon. It's not something that's provided with the class because just in terms of general distribution, as well as the pandemic and for your safety, and frankly, because not everyone uses the book. And why is that, you ask? You're like, wow, Mr. Anthony, why wouldn't everyone just use the book? Well, well, the reason why everyone doesn't just use the book is because if you can see my screen here, there's actually an entire website that's dedicated and has every single practice test for you, right? So it has practice test 1, practice test 3, 5. So this is everything that's inside of the book that's made available to you guys electronically, okay? Now, of course, I would suggest for you to keep a separate notepad, right? Monitor your incorrect as well as your correct questions. We refer to that as kind of your incorrect answer log. But at the same time, if it's easier for you to end up getting this book just in general, rather than printing test after test or writing down problem after problem, then you can simply just order it online. I think it's anywhere from like $15 to $18, okay? But we will intentionally provide every link to you guys via, in terms of this class, so we can share the screen and make it easy for you. We will provide everything to you, okay? Just in general. So if you have any general questions regarding what we're covering or where it can be found, just let me know and I will gladly provide it inside of the chat. All right, guys, so today, and I'll circle back to this, today we're going to be talking about SAT math. So before I hop into this, I'm going to spend a quick minute just answering any previous questions you guys might have had. So let me log in here. Alyssa asked, if no points are deducted for wrong answers, does that mean that each answer choice holds a certain point value? Well, that's interesting. Um, every answer choice actually does hold a certain point value, but it's not based off of it's not based off of the number. It's actually based upon the level of difficulty. So what the SAT is, it's a full commute like what's the word I'm looking for, like summative score essentially, but it's based off of a percentile. So a percentile means that you need to outperform individuals who are also taking the test, essentially. So like what the definition is of good or bad is relative, right? It's relative to what is like what you're being compared against, and the percentile means that you want to outscore or essentially outperform a larger percentile. So let's say you tested in the 99th percentile, that means you were outperforming 99% of the other students who were taking the test. Um, to generally, so what how the SAT goes in terms of scoring is that everyone takes the test. They intentionally have easy, medium, and hard questions built into the test. And then based upon the number of students that are getting the amount of easy, the amount of medium, and the amount of hard questions, then there is a curve essentially that is assigned in terms of the percentile score. And that's why not every test is exactly scored the same way. But more important than understanding all of the scoring is honestly understanding the test, because what you want to do is put yourself in a position where you understand what the questions are asking, and that's the most important thing, right? You focusing so much on the scoring is rather than the fundamentals as well as the interpretation is going to be an issue, right? And we don't have a lot of time right in class to review everything, so that's why we're going to spend more or less we're going to spend more time focusing on the actual strategies. Okay, so let me jump into it a little bit. And Alyssa, I hope that sort of addressed your question fairly vaguely. The SAT math section. Let me slide back here just in general. The SAT math is going to cover your algebra 1, your geometry, algebra 2, general intro to statistics like mean, median, mode, range, some basics of trigonometry, and data interpretation. Data interpretation is when you see like visual graphs and things, or like line if best fit generally, right? That's what data interpretation refers to. You have a math non-calculator section, which is 25 minutes and it is 20 questions. There are open-ended questions, which means that you will need to fill in your own answer. And I'm actually going to show you guys the test. I'm going to walk you through it. But just in general, I want you to get a general understanding of algebra 1 and algebra 2 actually make up about, I would say, over 50% of the test. So if you might have struggled in those classes for whatever reason, you go and make friends with your algebra 2 teacher and go and sit down and see if you can just sort of see them after class. And if you're currently in algebra 2, then try to understand that what you're learning in class, how it's going to be formalized in the context of the SAT, right? Because the SAT will ask questions slightly differently, yet it will be the same content, right? You will need to know the foundations of that content. And it could be anything from, let's say, complete the square or equation of a circle to parabolas and vertex form, right? All of those things, the SAT assumes that you already know how to do, and now they're going to apply them to a test interpretation, right? In terms of kind of understanding the strategies and what to look for. The math section, the fourth section, is a math calculator section. It's 55 minutes. It's 38 questions. It does focus on the same concepts: algebra 1, geometry, algebra 2, intro to statistics, trig, and data interpretation again. And once again, algebra 1 and algebra 2 do make up the heart of the test. You'll get a few questions for statistics. You'll get maybe 1 or 2 questions that are kind of related to trigonometry, but it's also kind of a bridge between advanced algebra 2 and trig. And you'll have a few questions related to geometry, whether it's like angles, lines, triangles, circles, etc. And if there's certain things that you would like for me to cover in a particular order, just let me know, right? Just let me know, and we can make time to do those things. Okay. Now, why am I sort of illustrating that to you? Why am I telling you, okay, well, this is kind of what you expect when you're taking the math section, okay? It's because it's to give you a general idea that for this class, unfortunately, we don't have time to teach you 4 years of math, right? We don't have time to teach you everything you've learned in Algebra 1, everything you've learned in Algebra 2, everything you learned in geometry. And by the way, if you've never even taken trig, we don't have time to teach you trig and then teach you the SAT. So what you want to do as best as possible is familiarize yourself again with those concepts. So go back and review those things, pull out that Algebra 2 book, right? Pull out that geometry book if necessary. Because, and I'm gonna teach you the trick. This is by far the most important slide that we are going to cover today. It's only one slide, okay? This is it. This is how you crack the SAT math section, and I'm going to show you exactly what I mean, so that way you guys have a better understanding of it, essentially. But the way that you approach any SAT math problem is based upon 3 steps. Okay, the first step is you're going to read the problem and you're going to do your best to identify that type of concept. This is where your previous knowledge comes into play, because if you don't know that the question's asking about exponents, or if you don't know the question's asking about linear lines, or if you don't know the question's asking about ratios and proportions, then that's not an SAT thing. That is your previous foundations of saying, hey, I forgot circles, or you might have happened to forget triangle rules, or maybe you don't remember exponent rules. That is more relatable to just your math foundations. Granted, we're going to review those things, right? We're going to make sure to put you in a position of success. But for you, in order to really crack, I would say like a 1350 or higher, you need to be familiar, like very familiar in terms of the really in terms of the math, right? You need to know what you're looking at, right? You need to look down at a problem and say, this problem is assessing equation of a circle. This problem is assessing triangle rules. This problem is assessing ratios and proportions. So that's the foundation. Almost like in grammar, when you look down and you say, this is concision, this is parallel agreement, this is subject-verb agreement, this is, this is commas and semicolons. You have to be able first to interpret what the question is asking. That's rule number 1. Rule number 2, and this is by far the most important thing. Believe it or not, this is the SAT, like, this is the golden rule of the SAT, okay, with respect to the math section. They give you information intentionally, and the information they are going to give you, you need to figure out how to use in order to answer the problem. The information is there purposely. It is not there just because. And if you figure out how to use the given information that they are giving you, that, by the way, is related to the concept, if you figure out how to evaluate what is given in the problem and think, how can I use this as a tool, then it makes it easier. If you do not make this connection, then you are not solving it according to the SAT. That's the easy way that I can describe it to you. The SAT is intentional, that they give you information. And by the way, this is a good thing, right? This you're probably thinking to yourself, like, Mr. Wyckoff, this doesn't sound fun, right? Like the idea that I'm purposely giving you things that are like clues in order to solve this problem that's a puzzle, you know that the clue is there on purpose. So it makes it easier for you then to think, how do I solve this problem, I would say, more efficiently, knowing very well that what they're giving you is a clue, okay? And then you want to basically solve the problem by connecting this given information, okay, to what is that necessary math computation. The necessary math computation, by the way, is the concept. The concept is like, hey, do you need to know volume of a sphere, or area of a triangle, basically. That's where this comes. But your goal is to figure out what the relationship is, why are they giving you that information, and then how do you connect it in order to solve the problem, okay? Also, quick tip, and you might like this, is that when you actually go into your SAT, let me erase this, by the way, when you guys actually go into your SAT, what you're going to notice, let me slide this over here, okay? And by the way, let me just check the chat real fast to see if you guys have any kind of general questions so far. No, okay. Now remember, the link is already posted there for you. So that way you have it. But if you need anything again, just simply let me know, and I will kind of hyperlink it back for you. Matter of fact, I'll just do that now. That way, if there's anybody that's joined us a little bit later on for whatever reason, okay? I know that Zoom has a unique functionality where if you log out and you log back in, but I post something during that time in the chat, you actually don't have access to it anymore. So that can be a little bit of an issue. Also, you guys might like this. Everything is going to be recorded and it's going to be sent to you intentionally. Okay, so everything is purposely going to be recorded, so that way you guys have this information. Okay. All right. Let me hold on one second. Actually, let's just make sure that indeed we are recording. And yes, we are. Okay. All right. Just making sure. All right, guys. So what you're going to do when you go to the SAT test, essentially, is one thing I will recommend right off the bat, and we'll come back to this, but there's going to be certain equations that I would recommend for you guys to put on the test, like on the test booklet, because by the time that you get to the math section, it's going to be about 2.5 hours into the test. So you might be a little tired, right? It's going to be about 2 hours into the test. So you might be a little tired. You might be forgetting certain things. So what I would suggest is, and I will tell you what those equations are when the time comes. I don't want to overwhelm you right now, but the very first thing you do when you generally get the test and you have the proctor sort of speaking to you and you're filling out the information is that sometime during that time frame, I'm going to give you a list of equations for you to write down. And those equations will help you, because by the time that you actually get to the math section, you'll have remembered, okay, well, you can use them as the resource. Now, why am I telling you this? It's because when you actually get to the math section, and we'll focus on section 3 today. Okay, when you actually get to the math section, section 3 is the non-calculator, by the way, just in case if you forgot what I had mentioned a moment ago. For section 3, one of the nice things is that, look, they give you a big reference section, and you're like, oh my God, they're so nice. That makes it a little bit easier. I see a question here inside of the chat. Will you post or send the link for the book on the Amazon? I can send the link to you guys via email. So there's a weekly homework and announcements email that goes out to everyone that essentially is here for the class, and the video and everything else actually goes out to those individuals. I see here this is an anonymous attendee. Not quite sure who you are, but let's just say if you're supposed to be here, you get all the information that you're supposed to have. Okay. All right. So the math test starts 25 minutes, 20 questions. You're not gonna read the directions on test day. That's not something you're essentially gonna need. I'm gonna walk you through kind of what to do. For section 3, the use of a calculator is not permitted. All the variables and expressions used represent real numbers. The figures provided in the test are drawn to scale unless otherwise indicated. All figures lie in a plane unless otherwise indicated. Unless otherwise indicated, the domain of a given function f is a set of all real numbers x, which is the f of x is a real number. To be fair, you're not going to care about the directions and you're not going to care about the notes, right, on actual test day, because you're going to be so familiar with actually taking tests, right, or actually taking the practice problems, it's not going to be that much of a difference to you. The section, however, you will care about is the reference section. And I'll even help you out. I'll point you in the good direction. You will care more. So what I'm gonna do is I'm gonna quickly kind of highlight the equations that are used most often. And in the email that I send you guys in terms of homework announcements, I'm also gonna add additional, I'm also gonna add the most common formulas and equations that the SAT typically uses, even if it doesn't appear here on this reference section. So area of a circle, area equals pi r squared. Circumference of a circle, circumference equals 2 pi r. They love to use Pythagorean theorem in some case. They love to use area of a triangle, and they love special right triangles. Okay, you will absolutely have you will absolutely use 1 or 3 of these, right, in some capacity. You will have some sort of question, more or less. It's always usually circumference. And they will generally do arc length equations, which I will show you when we get to it, or they will do area of a sector equations, which I will also show you when we get to it. In short, okay, and this is the easiest way to look at this, is that if they ever show you a polygon, by the way, a polygon is a shape, right? Essentially, if they ever show you a polygon and they mention the word volume or they mention the word area, you immediately want to think about your reference section, okay? Just to make this easier. If they say triangle, circle, rectangle, and if they say the word volume or if they say the word area, you want to immediately identify most likely you can use something out of the reference section in that capacity. Okay, so that's rule number one, for technically, I guess, rule number two when you're taking the SAT. Rule number one, okay, just in case if you happen to, you know, join us a little bit late, rule number one is this. Rule number one, and it will be rule number one forever and always for the SAT. Rule number one is this: you need to figure out what is given and how to use that in order to solve an SAT problem. Okay, that's rule number one on the SAT. What is given, and figure out how to use that when you're doing the SAT. Rule number two, I guess, if we're gonna, you know, start throwing some rules out, is you want to, if they say volume, area, perimeter, and they throw out the word polygon, and they're referring to the reference section. Okay, so you want to use this in terms of your reference section. All right. So I hope that helps kind of clarify a few things so far. Let me quickly check the chat. From a student who works with Embrace before, their YouTube channel is a huge boon. Yeah, thank you, Youssef. Right? So, yeah, the YouTube channels. No, we actually intentionally keep a few videos like locked because they're too revealing and they're only for the private tutoring students. But for you guys, you get right. You get it all, right, in that sense, because of the fact of the class, and you get the level of personalization. So feel free to let us know if there's anything that you want us to cover specifically, and then we will gladly go over it. Okay, so now as I work through the math section, so let's take a gander, all right, at what some of the questions look like. So here you have general kind of like literal equations or plugging in, right, algebraic expressions. Here it looks like I have or imaginary numbers. Here it looks like kind of like a slope-intercept form where y equals, right, mx plus b, or like this looks like a linear equation word problem. Here looks like literal equations because this is p, 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 p. Now, granted, I'm mentioning a bunch of terms, but what I hope is that when you look down at these problems, the little bell in your mind goes off and says, oh, I remember when I learned this in math, right? That's the first thing that should happen, because you need to know the concept so that way you can identify it and understand the rules of the game pertaining to that concept, because math compounds and it has different strategies for different types of problems. So the first thing you want to do is just be familiar with what the math is, okay? The second thing you then want to do is understand SAT-wise, how do you solve for that, right? How do you make that connection, right? This is simplifying expressions, right? X squared, y minus 3y squared. And technically, I guess you would refer to it as like simplifying trinomials, I think is the technical term. Right, literal equations. This looks like some sort of like system of equations or putting the equations together. This looks like systems of equations, which they even state. This is a slope. This looks like coordinates and lines. Here we have functions and substitution, because it says g of -4, and here's our equation. So you guys kind of get the idea, right? You kind of get the idea that it's going to be a little bit of a kind of like a hodgepodge of everything all together. But what I'm going to quickly do is I'm going to show you exactly what I mean and I'm going to use number 14 as a guide. And I've done this problem before, but what I've come to find is that 14 and 15 usually are the best when students are trying to remember this, okay? So I see here I have a quick question. Let me look at nope, okay, we're good to go. Usually 14 and 15 are the best when we're trying to figure out, or when we're trying to think about SAT math in that regard, which is, I want to figure out, okay, one, what's the concept here? Two, what is given inside of this problem and how can I think about how to solve it? And then three, how do I solve the problem, right? Making that connection, essentially, All right. Remember, this is always how I want to think about SAT math. And I'll tell you, I've worked with students. I've worked with so many students where they've gotten like perfect scores or near perfect scores, or they improved by 300 or some odd points. If you understand first how to approach it, like think about the game, so to speak, then everything else becomes a lot easier, right? As you're sort of filling the blanks, and we'll review the we'll review the math, we'll review the exponents, we'll review the quadratics, right? We'll review all that stuff. But the first thing you guys have to understand out of the gate is basically when you look at a problem, how should you think about the problem? Okay, that's the first thing. When you look at a problem, how should you be thinking about the problem? All right, guys, let's minimize this. Let's go back to this question. So remember, whenever we look at a problem, one, I want to identify what the given is. So I want to remember from Math 101, what were the things that I learned in the past, and how will they kind of basically be involved when solving this problem. Number two is I want to figure out, oh, sorry, this should be concept. This is concept here. Okay, then I want to figure out what the given is. And then I want to identify, okay, what is the given in this problem and how will I use it in order to correlate to the concept? And then three, what steps will I need to take mathematically in order to solve the problem? All right, this is always my three-step process. So anyone inside of the chat, if you guys can tell me, what concepts do you see? What mathematical things, right, do you see when you see 8 to the power of x over 2 to the power of y? Because by the way, I'm circling this purposely because this is one it wants me to solve for, okay? So tell me, anybody, okay, tell me what concepts do you see? Like, do you see probability? Do you see ratios? Do you see quadratics? Like what in the world of math, when you guys were learning it way back in the day, right? What do you see? Exponents that are variables. Yeah, and Max, awesome. Great job. Nick, great job too, right? So what it is here is exponents. That's your concept. So if you remember, okay, this is exponents. That's good. That's the concept that they're assessing. Now, anyone want to take a stab at what the given is most likely going to be, right? Because it says if 3x minus y equals 12, what is the value of 8 to the power of x over 2 to the power of y? Anyone want to take a stab at what they think the given most likely is going to be? Let me go here. Let's go back to the chat. All right. All right, for time purposes, 3x, yeah, Joanna, good job. And Joanna, I'm happy you were able to get on, by the way. Yeah, so this is your given, guys. Which, look, here's what I mean by this, okay? Just so we're kind of all on the same page. And look, we are going to cover so much more math. Today is more of a housekeeping, as Miss Caitlin was suggesting. We have to teach you guys what to expect and like how to think about things first, and then we sort of tear through. Okay, but you got to learn the rules of the game first. Now, what I'm generally getting, and bear with me, okay? What a lot of students tend to do when they see this problem, okay, is they like to first solve for like y or x. So I'll do that. I'll solve for y or x. So I'm going to teach you the bad way if you don't understand it SAT wise, and I'm going to teach you the good way, right? If you do understand it SAT wise. So that way you can solve this problem without ever writing anything down. You're like, no way, crazy. All right, so here's 3x minus y equals 12. What you can do, all right, is that let's pretend I want to add the y to the other side, right? Let's say I want to solve for y. So this is 3x minus y equals 12. If I want to solve for y, I'm going to bring the y over here, and I'm going to subtract the 12. So minus 12, right, add y. I'm just basically going to flip sides. This becomes 3x minus 12 equals y. P.S. I hope you understand what I'm doing here. If not, this is going to get a lot faster, okay? So you need to go bring your algebra teacher some coffee. If this step here is like, what did he just do? Then then things are going to get a lot faster, right? Because we're combining like 4 years of math with every interpretive problem, all right? I'm now going to plug this in. Let's say I plug this in over here. So I'm going to do 2 to the power of 3x minus 12 on the bottom. So I'm actually going to do this, right? Just to erase this, I have 8 to the power of x over now 2 to the power of 3x minus 12. Okay. The issue is I didn't really help anything in this regard because the principle that I need to do, understanding exponent rules, I still have to do here. I actually just made it harder on myself though, to be fair. So here's the thing that you want to pay attention to. Like this is sort of like, hey, where do I go from here? This doesn't make a lot of sense. Instead though, if you were to think in advance, okay, why are they giving you 3x minus 12 and how, and I'll give you a quick tip, how does a to the power of x relate to 2 to the power of y using exponent rules? Now, you may remember that for exponent rules, and this is a quick tip, right? This is like a huge hint on the SAT, is that you want to work in the same basis, okay? So you want to convert to the same base. Because in exponent rules, if you get this into the same bases, it will then allow you the opportunity to do things where it's like, you know, if basically what I'm saying is that if I make these both a 2, right? Like if you remember like the products rule where it's like 2 to the power of let's say 3 and then times like 2 to the power of 1. You remember now, because of the fact that these are in the same base, I can now use this where this becomes 2 to the power of like 3 plus 1, right? If I add my exponents, which becomes like 2 to the power of 4. Well, likewise, let's imagine I have like 2 to the power of 5 over 2 to the power of 3, right? Because of the fact that these are technically the same base, that's what allows me to bring this up. And whenever I cross the fraction bar, right, knowing the fact that I have the same base, this then becomes 2 to the power of 5 minus 3, which becomes 2 to the power of 2, okay? Now, look, I know I'm combining a lot of things with respect to math, but once again, these are things that the SAT assumes you know how to do. Our job is figuring out the strategies and making sure that you're in a good place. We're going to review strategies, but we're not going to like sort of pause and do 20 questions on exponents. That's not how this is going to work, okay? Nor will we have the time. I wish we would. So my suggestion is if you have trouble remembering these rules and maybe for whatever reason, go and find your teachers, right? Start grassroots to help you review with, hey, why is this the case? Why is it that when you have 2 to the power of 3 times 2 to the power of 1, it becomes 2 to the power of 4, right? In terms of your product rule for exponents. Or when you have 2 to the power of 5 over 2 to the power of 3, and you switch this fraction bar here, knowing the fact that you have the same base, you actually subtract, right, the exponents, which I think is called your quotient rule, technically, right? So this becomes 2 to the power of 2. These things the SAT is going to expect you to know how to do so that way you can put it all together, all right? And the ACT for that matter. They both will expect you to know foundations within math. Now, here's the SAT strategy though that I'm telling you, is that you generally want to convert it to the same base, because if you do that, this will then become 2 to the power of 3 to the power of x over 2 to the power of y. Now, hopefully, this is making a little bit more sense to you, because look at this. This is 3x minus y. And look what I have now. I have a 3x and I have a y. That's not a coincidence, right? That's purposeful, because if you remember the other exponent rule, which I think it's the power rule technically, right? So here I have 2 to the power of 3 to the power of x, right? Remember, whenever I have an exponent to an exponent, I multiply these, right? So this becomes 2 to the power of 3x. It would be like the same as if I had like 4 to the power of 2 to the power of 3, right? This is a product rule. So this becomes 4 to the power of 6, right? This is referring to a product rule, right? This is a product rule. Now, if I have my product rule, and not to confuse you guys, I'm actually going to get rid of this here, right? I don't want you to think that this applies to this question. I'm just intentionally throwing out examples, right? So that way you guys can follow along. 2 to the power of 3x is now over, right? This is 2 to the power of 3x is now over 2 to the power of y. Well, guys, what did we just do, right? If you look here, right? I have 2 to the power of 3x over 2 to the power of y. Oh my God. Oh my God, right? 2 to the power of 3x over 2 to the power of y. Now, because of the fact that I can use my quotient rule, right, I can cross my fraction bar. And by the way, this is your master tip. You got it in the same base. Because of the fact you converted the 8 to a 2, and you converted these to the same base, now you can say this is 2 to the power of 3x minus y, which then becomes, anybody? What's going to be our answer then? If we know that 3x minus y equals 12, what does this become, guys? Let me check the chat. What does this become? Nicholas, Max, what do you guys got? Joanna? Right? If this is 3x minus y equals 12, it becomes 2 to the power of 12. That's it, right? So this becomes, this 3x minus y equals 12, right? This becomes 2 to the power of 12, right? So here's another master tip that I will give you guys to make it a little bit easier, okay? We've talked about how to solve the problems, right? The concept, exponents, using the given in order to solve, and then relating those concepts together, okay? But you can also use your answer choices as a guide, okay? Use answers as a guide. It will tell you sometimes, like you notice here in your answers, you don't have an X, you don't have a Y in any of your answer choices. That tells you that the step, in order to go from whatever is given to solve, you somehow have to get rid of X and Y, right? That's what it's telling you. It's telling you that the X and the Y have to be gone. So you want to try to make the connection. How do I use 3x minus y as a tool in order to solve this problem efficiently? And if I do this rather quickly, okay, so I'm gonna just erase this, and I'm gonna do like what you should actually do for test day. You circle this because this is what you're looking for, right? You always circle the thing what you're looking for so you stay focused. You then go back and you say, okay, if 3x minus y equals 12, this is a given. I'm gonna have to use this in some way. You then skim your answer choices to see what they give you as a guide, right, to help you. Then you say, oh, this is exponents. I remember that day way back when Mr. W said, oh, if I ever have exponents, right, then I probably want to solve for the same base. So I'm going to convert this to 2 to the power of 3 to the power of x over 2 to the power of y. Then you would say, all right, well, what is given? How do I relate it to what is given? Oh, here I see a 3x and here I see a y. That makes sense. So my step that I'm going to do, because I don't see an x and a y in my answer choices, I'm going to multiply these, and I get 2 to the power of 3x over 2 to the power of y. Oh, well, now I'm going to intentionally subtract because I have a minus y. So I'm intentionally going to subtract this and bring this up because it then becomes 2 to the power of 3x minus y. I wouldn't subtract it unless that's what the given was. That's what I'm trying to get at, is that the conditions, what you do to solve the problem depends upon the conditions of which they give you. What you do to solve the problem depends on the conditions of which they give you. So you might not subtract this if you didn't need to subtract it. You do need to subtract it because that's the given. And that's what you're trying to get to. That's the tool that you're trying to use. And then if I know that 3x minus y equals 12, I notice my answer choices are, right, there's no x and y. That's what makes this 2 to the power of 12, and I'm done. That's how you do SAT math, okay? You use the answer choices as a guide. You circle the thing that you're trying to figure out. You remember, hopefully, what the concept is mathematically, right? That's the starting point. To be fair, that's the starting point. You remember the concept mathematically of what you're trying to solve, and then you use the given in some way as a tool, okay? That is how you do SAT Math 101, and I honestly hope, if anything out of the last like 5 to 10 minutes of what you guys got out of doing this problem, I hope it becomes more approachable, right? I hope you guys feel more confident doing the SAT in this manner, knowing very well that it's able to be solved if you understand and how to use things as a tool, okay? All right, let's try another problem, and then we'll move forward. Let's do number 15, which also seems like a little funky, but hopefully you remember right? The rules of what I'm telling you, that everything, right? There's a given. You want to figure out like what the concept is, most likely. You also want to remember what is given, okay? And then finally, you want to figure out how to solve it, like how to relate it to the problem. So let's figure out all the different parts of what are given, so that way it makes it easier for you guys. Here I have if ax plus 2 times bx plus 7, these both look like binomials. I think that's the classic term we refer to, equals 15x squared plus cx plus 14. This looks like a foiling problem. Hopefully you recall that as well. For all values of x, it says and a plus b equals 8. That's not random. That's there. That is part of a given, okay? That's part of a given. A plus b equals 8. What are two possible values of c? Well, where is c? First of all, I'm going to circle this because I want to stay focused on what I'm looking for. And c is your middle term, right? Now, what this tells you is that if this equal sign is true, then if I do, let's say, ax plus 2 and my bx plus 7, if that equal sign is indeed true, that means that if I FOIL this, I can set that equal to these things, right? So here's what I have. I have ax times bx is going to be abx squared, and then ax, right, times 7, which is going to be plus 7ax. And then I know, well, actually, to tell you the truth, I'm doing too much too soon. But you could do the FOIL here. And here's the reason why I'm saying I'm doing too much, is because this I need to use in some way, and which means I need to relate A and B. And I think I actually can do this rather quickly if, and you guys are going to see what I mean, but abx squared is going to be equivalent to 15x squared, right? Because these are the numbers out in front of the coefficient. So ax times bx, like this, is what gives me 15x squared. So I know this equals this, okay? And once again, I can continue foiling if I want to. I can do ax times 7 is 7ax, 2 times bx is plus 2bx, and then 2 times 7 is 14, okay? So this 14 is true, this 14 is true, and then the other 14 on the other side would be true, okay? So I guess let me sort of reorganize this for you guys so you can see it. abx squared plus 7ax plus 2bx plus 14 equals this, 15x squared plus cx plus 14. So the 14s match up, which work, which means the 7ax plus the 2bx is going to equal the c. And here's the kicker, the abx squared is going to equal the 15x squared. That's honestly what I want. And the reason I want that, and hopefully you can sort of connect the dots, is because they're giving you this. They're giving you a plus b equals 8. So here's what you know. abx squared equals 15x squared. If I were to divide both sides in order to get, right, to simplify this, I would divide the x squareds out for both sides. These simplify and these go away, right? Because they're on both sides of the equation. That tells me this, ab equals 15. A times b equals 15. Now, can you take a wild guess which two numbers, when multiplied together, will give you 15? But, and here's the thing, when added together will give you 8, okay? Because you know a plus b equals 8, a times b equals 15. Take a wild guess which two numbers these are. And I'm loving the participation, by the way, guys. Yeah, 3 and 5. Yeah, awesome. Thank you, Valerie. Thank you, Andrew. Right? So does it make, do you guys see, like, is this making a little bit more sense to you of like how to think about the test and kind of how to approach it? Something is given, it's there as a tool, right? It's a helpful thing, right? And then once you figure out how to crack it, right, it makes it a little bit easier. And then what I'm gonna do later on as we go through more of the tests is basically between Mr. Hansen and I, as we're doing the math together, is we're gonna teach you guys some strategies that are unique to certain types of problems. Okay, we're going to teach you guys some strategies that are unique to like a few different types of problems. That way it helps you guys out. All right, so yeah, 3 and 5. So what do you think we're going to do with A and B? Right? What do you think? We think that A equals 3 and maybe B equals 5, or maybe B equals 3, right? And A equals 5. Take a wild guess what we're going to do in order to verify what we think the value of C is. What do you guys think we're going to do? Let's boom, boom, boom. Some chat. Add them into the equation. Yeah, we're going to plug them in. Good job. That's exactly what we're going to do. So let's plug them in. Let's make it easy. Here we go. Let's minimize this. So I'm going to erase everything. By the way, take screenshots along the way. Everything will be recorded for you, but take screenshots along the way, so it makes it easy. All right, so all I'm going to do, I'm going to have like A equals 5, B equals 3, okay, B equals 3, like this, A equals 5, and I'm just going to plug them in. I'm going to do 2 different versions just to double check, just to make sure. I noticed that these numbers here are all different, which helps, right, as I use this as a guide, but just in case if the numbers were similar, I would purposely do it both ways. So this gives me, sorry, already off to a typo. All right, so this gives me, let's say 5x plus 2 times 3x plus 7. And this will give me 3x plus 2 times 5x plus 7. Now, guys, remember, when we FOIL, right, we're a quick crash course for FOILing, first times first, right? So 5x times 3x is going to be 15x squared, right? Because of the, I have to take, because of the x's, it's x to the first times x to the first. I have to combine and add the exponents together. 5x times 7x is going to give me 35x. 2 times 3x is going to give me 6x. 2 times 7 is going to be 14. So my middle term, which should be C, looks like I need to combine my and simplify my like terms. 35 plus 6 is 41. 41 should be C in this regard then. So it looks like my answer is going to be D. Let's double check just in case. 3x times 5x is 15x squared, which once again works. 3x times 7 is going to be 21x. 2 times 5x is going to be 10x. And then 2 times 7 is going to be positive 14. So the 14s work, 15x squareds work. So here I have 21x plus 10x. I'm going to simplify my like terms again. And I get 31x, which means C is 31. So D is definitely my answer, okay? And now, I probably, to be fair, I probably just would have done one of these, checked, done, circled, move on, right? But the reason I'm showing you both ways is just in case if your answer choices would have had like 6 and 41, 31 and 41, right? Then it helps to be able to plug it in both ways just to verify that indeed is going to be your answer choice. But as I look down here at the problem, remember the way that I solve this is figure out what they're giving you, right? Figure out what they're giving you, and then how does it relate to the question being asked. Also, you can't do this problem if you don't know how to FOIL, right? If you have no idea how this equation is being derived mathematically, you're going to have some serious trouble. That's why I'm saying grassroots. If you've never seen this type of trinomial concept before, or multiplying binomials together, if this is completely foreign to you, this is something that, and if this quick, right, 5-minute intro maybe not have done it for you, that's something you want to go and review in your Algebra 1 book. Also, and simply go and speak with your math teacher, right? So you get a stronger foundation of what is this math concept and kind of how are we going to apply it to the style of the SAT. Okay, we're going to fill in all the SAT blanks, but we are expecting you to know how to do certain math foundations so that way things are a little bit more in a rhythm. Okay, all right, let's get out of this. I'm going to show you 1 or 2 questions that will help you before we move on to some other things, and then I will let you guys pick just a general concept like, hey, Mr. Wonkoff, I would love to learn how to do these types of problems, and I will gladly kind of walk you through what to expect. Now, granted, every week you guys will be doing a practice test, and then we're going to review certain concepts from the practice test to make it easy for you. But just to kind of keep things in a steady rhythm, I will give you guys, actually, I don't think it has the type of question that I'm looking for. My apologies. But anyways, to keep things in a steady rhythm, if there's certain questions that you guys have as well, you're always welcome to reach out. All right, guys. So what I'm going to do is I'm going to jump to this practice test real fast. I hope that doesn't confuse anybody, right? So what I'm going to do is I'm going to go here. I'm going to go into the chat. And then one of the reasons I'm jumping to this test, which is SAT practice test 8, is because there's a type of question that is always the same, okay? So there's a type of question that's always the same. And for this type of question, I just want to teach you like quickly how to hack it to make it easier. All right, so you want to go to this practice test that I've just sent you, so that way you're in a good spot. And where we're going to go is we're going to slide down, and I'm going to go into section 4 of this test. And if you can't find it, it's fine. Just feel free to kind of follow along, because I'm going to break it down for you regardless, okay? And before we kind of move into some of the other problems, I just want to kind of teach you guys some of the hacks first, so that way you guys understand how approachable the test can be. And still didn't find it. Okay, maybe it's in section 3. Also, inside of the chat, to save some time, if there's certain types of problems that you would like for me to start with and cover, let me know. Otherwise, I will gladly, essentially, I will gladly kind of review using the easier problems first, and then moving and kind of scaling to the harder problems, okay? All right, so the question that I want to go over is number 7. And here's the reason why. Number 7, technically, I would consider to be more of a medium problem. But this is going to kind of be a quick crash course regarding like quadratics and radicals and things of that nature. Here's the thing about this problem here, is that if you were to actually set this problem up, okay, let me go back. This is radical 2x plus 6, and this is plus 4 like this, equals, and then I have x plus 3, okay? If I were to do this problem in a regular fashion, this is how I would set this problem up. So just a review of general math. I would subtract the 4 first, and to remove this and get the radical by itself. I would then have my radical 2x plus 6 equals x minus 1, right? 3 minus 4 is minus 1. And then, in order to remove my radical, I'm going to square root both sides. And hopefully you kind of recall, hey, well, this is like a binomial. So if I square root this, that is the FOIL method, again, which is why I'm intentionally doing this problem right after the other problem for what we were doing. My radical here is then removed. I then have 2x plus 6 equals, now remember, this is x minus 1 squared, so I can expand this so you guys can see it. And I'll put this in a different color ink so you can also not get confused. This is 2x plus 6. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is minus 1x. Negative 1 times negative 1 is positive 1. I'm going to combine these to get like terms. I'm going to get x squared minus 2x, and then positive 1, and then this becomes 2x plus 6, okay? I'm now going to subtract my minus. I'm going to try to get everything onto one side, basically, so that way eventually what I can do is factor. Because here, right, this was a foiling method. This was in order to remove my radical here, and what I'm trying to do is eventually get this so I can solve for my factors. If I subtract, actually, I'll also do it this way. If I subtract 6 on this side, and if I subtract my 2x here, then I get this to be a 0, which becomes 0 equals x squared minus 4x minus 5. This is my new trinomial, which I can factor. And if I'm going to factor this, remember, if you're factoring things, right, remember, crash course, okay, is that I want to figure out which two terms, when multiplied together, will give me a -5, right? So I'm going to think of multiples of -5. In this case, it's most likely going to be a -5 and a +1. So -5 times a +1 will end up giving me -5. Now, the reason why I chose +1 is because for this term here, I need to think of which two terms, when added together, will give me -4. So this would be -5 plus 1, right? This will end up giving me -4. Notice if these are the same multiples, then those are the numbers that are going to go inside of here, okay? So this is my x squared. Sorry, this is my x, this is my x. Then I want to choose, let's say this is -5 and this is +1. You can always check this if you guys want to make sure that you're in a good position, right? As we're checking it. And if I check it, then what you'll end up getting is x times x is x squared, x times +1 is +1x, -5 times x is -5x, -5 times +1 is -5. Notice if I combine my like terms, I get x squared minus 4x minus 5, and ta-da, right? That's what I was starting with, so therefore this works. Which tells me, now here's the trick, these are my factors, okay? And technically, if you remember, I should have set these equal to 0, right? Because this is actually set equal to 0. So, and I'm giving you like a quick crash course of this lesson, but I have 0 equals x minus 5, and then x plus 1. What I can do, because these are technically considered to be my factors, I now want to solve for what you refer to as your roots. Your roots are when you make this equal to 0. So this becomes x minus 5 equals 0, and this becomes x plus 1 is equal to 0. I now can solve for x, which you get x equals 5, x equals -1. Okay, so cool. We went through that entire process. Yay. Right? Here's the issue though. In order to check, right, for discontinuous solutions, what I have to do is I have to plug these in, right? I have to plug these in. So here is your hack to make this easy for you, okay? Here's the thing that you want to do when you get to this problem. You're going to be, Mr. Ryan, why'd you do this entire thing? The reason I did this was to show you the math, because you need to be able to do this type of math for other types of problems, which we will get to. But nonetheless, what you want to do whenever you see a radical, okay, whenever you see some sort of radical here, and here's your master tip, whenever you see brackets, if you see a bracket, or you see the other way they do this is Roman numerals, okay? If you see a bracket or you see a Roman numeral, what you want to do to make this easy for you, okay, is you just simply want to plug these in. You want to take these and you want to plug them in, because if you don't plug these in, this is to guide you anyway, because look what happened. That's what I solved for anyway, right? That's what made this easy. Hold on one minute. Let me just, I'm not gonna update my computer right now, but for some reason. Okay. So here, right, if I go back, let's cancel this, right? Cancel. Right. Apologies, guys. So, right, what you want to do anyway, so you don't have to do all of the math, strategy 101 is just whenever you see a radical, whenever you see these little brackets, plug them in. Plug them in, because that's what you're going to have to do mathematically if you solve it in order to check for discontinuous solutions. So I'm going to take this -1 and I'm going to plug it in. And if I plug this in, I do 2 times -1 plus 6. Notice all under the radical. This is under the radical. Plus 4 equals, this is -1 plus 3. Okay. The right side is fairly easy to solve. That's 2. -1 plus 3 is 2. The left side is 2 times -1, which is -2, and then plus 6 gives me 4. Okay. -2 plus 6 is 4. I get radical 4 plus 4. Here's the issue though. Radical 4 is 2 and then plus 4, and this is 2 on this side. 2 plus 4 is 6. So 6 does not equal 2, right? So that means that -1 is doesn't actually work, right? 2 times -1 is -2 plus 6. So radical 4 breaks down to become a 2. and then I still have my 4 here on the outside. Yeah, so this won't work. This is off. Now let's try 5, right? Because notice all my answer choices here are -1, -1. Technically, B's got to be the answer, right? It's the only one without -1 inside of it, which is why I intentionally tried it first. But if I plug this in just to verify, and I'll put it over here, right? 2 times 5 plus 6, and then plus 4 equals, and then what is it, 5, right? 5 plus 3. So 2 times 5 is 10, plus 6 is 16, radical 16, then plus 4 equals 5 plus 3 is 8. Radical 16, remember, whenever you're doing a radical of something, it's which two numbers multiplied by itself, right? Like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So that would be the radical of 16. So radical 16 is 4 plus 4 does equal 8. So this does work, right? 8 equals 8. So 5 will be my answer choice. Why did I show you how to do this? Because even though the math is necessary in some elements where you have to be able to understand the different types of problems, I will say there are certain strategies on the SAT, like such as when you see a radical and here you have the brackets and the Roman numerals, go to, right? Immediately just plug it in, be able to solve for that as you're working through. All right, guys. So let's continue on and let's do our best to sort of solve through as much of these problems as we can. And where I'm actually going to go and start is I had a chance to send you a document, and the document that I intentionally sent you guys before, let me sort of slide over here. One of the documents that I sent you before, it looks like this. It's Embrace Tutoring slides, and it's going to break things down in terms of all of the concepts. So for what we've done for this here, and you guys get access to this, is that it will, and this is sent to you via email, so you're more than welcome to open it up, and we'll send it again, by the way, so you guys have everything. Is it breaks everything down. And one of the things I will say is that the problems generally go, like these types of concepts generally go from like easy, medium to hard, with a little bit of, mixing between what you would consider to be medium and hard. But for the most part, every single one of these problems will pertain to a certain concept. So what we've done is we've categorized all the problems for you and in every single problem in the practice test, right? So every single problem in this practice test, we have categories for it. We say, oh, this is linear models, this one's ratios, this one's exponents, this one is triangles, right? So we have collections of problems specific to that concept, because what our students do is they will attempt certain problems. If they get stuck on that problem, and here's a master tip, they will then go back into those types of problems, and that's how they know what to focus on, right? So it's not that they're poor at SAT math, it's simply just that they need to improve on a certain list of concepts in order to enhance their skill overall. Then that is generally how it's targeted and how it's focused, and that's how the students do so well, right? So I'm gonna slide down ratios and proportions concepts, and I'm gonna do here, and I'm gonna start going through several of these different types of problems. I'm gonna break it down for you in terms of like what to expect, and then we're gonna move on to other different types of concepts. But I will say before I move into ratios and proportions, if you guys could just take a quick moment to just tell me what concepts would you potentially like to cover? Because one of the things that I will do with Mr. Hansen next week is we will coordinate and we will go over the concepts that you guys want to learn first. We're going to do them all anyway, right? But tell us the different types of problems that you guys might want to see first that you think you need the most help with. As you've taken your PSAT, or different types of concepts. We've done a foiling problem, right? We just did a radical slash kind of like factoring problem. We've done an exponents problem, right? What are some mathematical concepts that you guys generally have trouble with the most? And then feel free to just put that in the chat, so that way we can kind of coordinate and get it factored. Okay, yeah, we can cover some factoring problems. Let's see. Feel free to keep going. Thank you, Stephen, for weighing in. But if anybody else, parabola, vertex form, okay. I would say most of the parabola vertex form problem are usually the more advanced on the SAT. So thank you, Connor. Any others? Okay, vertex. Open-ended. Okay. All right. So let's do this. And anybody else, feel free to weigh in. But I will let Mr. Slope intercept form. Okay. All right. So let's move into this. I'll do a couple of the ratios problems. I also I will do. I'll find one in your test actually, and I will find an open-ended problem so you guys can see what to expect. Now I'm gonna, nope, that's section 3, sorry. And I'll do one of the open-ended problems because this is a good one in terms of factoring, right? This is another kind of good one in terms of factoring. We can do circles if you want, right? We can do all these things. And let's see here, okay. All right, for number 16, and to kind of tackle this concept slightly, here's one thing I will tell you in terms of open-ended that you guys hopefully will love. Whenever you're doing any sort of open-ended problem, okay, so I'll give you kind of the quick crash course of open-ended. Whenever you're doing any sort of open-ended problem at all, there's 3 things you want to be aware of about open-ended problems. The first is they're always positive. The answers to the open-ended problems are always going to be positive. They have to be positive because if you actually look at the answer where you can bubble things in terms of your open-ended, you notice there is no negative sign here that's available to you in terms of bubbling them in. And for those of you that don't understand what an open-ended problem is, an open-ended problem is where the SAT will check your actual arithmetic, where you don't have the opportunity to just plug and chug answer choices. Essentially, you have to do the problem and you have to plug in your answer, which means that you have to kind of show your work in some capacity, right? You can't just plug and chug. And your answers will either be in fractions, like you see here, or your answer will be in a decimal form, or your answer will just be a whole number, right? It's gonna be a whole number, it's gonna be a decimal, or it's gonna be a fraction. You do want to try your best to put your answer as far to the right as possible. Notice here, this is like 2.5, so they're sliding it all the way to the right where it's 2.5, right? 2.5. But here are some things you don't see, and I hope this is like a huge tip for you, right? This is what, tip number 4, 5, maybe, something, right? All right, so here's a huge tip for you. There's no negative, which means your answer is always going to be positive. Also, there's no pi inside of your answer, okay? In answer. You don't have the ability to bubble in a pi. There's no pi here, right? So if you see pi, then it either means in some way that you're solving the problem, the pi is going to be canceled, or it means you have to multiply by 3.14, okay? And I will walk you through different strategies of as you approach this. Also, and you guys will like this, you don't have some sort of radical sign, right? There's no radical sign here. So again, you either have to simplify it, or what they generally do is they will put it under the radical and they'll say, okay, what's n? That's what they'll do. They'll put it under the radical in that sense. But there's no radical sign. So every single one of your open-ended questions, they are always positive. There's no pi inside of your answer, and there's no radical sign. You don't have the ability to actually plug that in, right? Now, hopefully that helps. And if anything, it makes you feel a little bit more confident as you're approaching the test. But let's break it down, right? Let's do a couple questions. I'll do some of these together, and then we'll work on even like slope intercept form if we have a little bit of time. Okay, so here we go. X squared plus x minus 12 equals 0. Because of the fact that I see a 0 here and I see an x squared, I know that this could be in what we refer to as a quadratic form. It says if A is the solution of the equation above and A is positive, A is greater than 0, what is the value of A? Well, whenever you see something in this form, and it looks like x squared plus x minus 12 equals 0. And if I want to break this down, the mathematical method that we're going to use to break this down is going to be factoring. Okay. And technically, I'm factoring what you refer to as a trinomial, right? Because it's x squared, x, and negative 12. So technically, I'm factoring a trinomial. That's the term for it. So this is what you want to do. As I'm factoring a trinomial, step number one, whatever the middle term is here, that is actually going to be your outside term, okay? In terms of like the variable. So if my middle term is x, then both of my insides are x. If my middle term is like x squared, then both of the insides are x squared, okay? That's step number one. Whatever the middle term is here, that's what it's going to be. Step number two, I want to figure out what my multiples are of negative 12. So I need to figure out, okay, well, negative 12, what times what, right? So question mark times question mark will give me negative 12. So I'm going to figure out multiples, kind of like do this little branch in my head of what gives me negative 12. Step number three, I know that this term here is a 1. So I need to figure out what plus what will give me positive 1. And hopefully, right? Hopefully, if this is factorable, which there are cases where it's not, and then we got to bust out the fabulous quadratic formula. If this is factorable, these multiples will match up, okay? So what times what gives me negative 12? Let's just run through some things. So negative 12 could equal 6 times negative 2, could equal negative 2 times 6. It could be, let's say, 4 times negative 3, or it could be like negative 3 times 4. Okay, so there you go. There's my little tree, right? In order for you to do this quickly, you have to be good at times tables, which frankly, we are so far past that I hope you are comfortable with times tables as we are preparing for the SAT, okay? 1 equals question mark plus question mark. So what are things that equal 1? Okay, 0, which not going to be the case. 0 is usually never a possible value here. So instead, it's probably going to be like 2 and negative 1, right? That's probably the easiest way to look at it. Because if I did negative 2, that wouldn't work either. It could be, I mean, the list is endless, but like if we look over here, it's probably going to be 4 plus negative 3, right? That's probably what my answer choice is going to be. So let me look here inside of the chat. What do you guys? Yeah, 4 and negative 3. Thank you, Valerie. Right, making sense. Right, so that's the idea. So how you factor, and granted, I do this so quickly, like in my head, but how you factor, it's always the same thought process. It's always which two things when multiplied together will give you the last term, but when added together will give you the middle term. Okay, that's always the way that I think about it. Which two things when multiplied together will give you the last term, but when added together will give you the middle term. And just so happens, 4 plus negative 3 and 4 times negative 3. 4 times negative 3, negative 12. 4 plus negative 3, positive 1. Now, let's do it. Let's check it. So here I have x plus 4, right, because it's a positive 4, and x minus 3 because it's a negative 3. The way that I can check this is I FOIL it. And if I FOIL it back, I get x times x is x squared. X times negative 3 is minus 3x. 4 times x is positive 4x. 4 times negative 3 is negative 12. These do combine. When they do combine, what would you know? I do end up getting a positive x, and that is what I'm using, right? So that's what I have. Now, however, here's the thing. I'm not done the problem. And the reason I'm not done the problem is because I haven't figured out my roots, which are technically my solutions. So what I want to do, knowing that this is equal to 0, is I want to set this up where this becomes x plus 4 equals 0, x minus 3 equals 0. I then want to solve for my solutions for each of these when I factor. So x plus 4 equals 0 becomes x equals negative 4. But remember, I'm in an open-ended section, and my answer always has to be positive. Not to mention, they're saying a is greater than 0. So you know that a is positive in some way, which brings us to the next one. X minus 3 becomes x equals positive 3, and there we go. Right? 3 will be my answer in this case. It will not be negative 4 because it doesn't meet the conditions of the problem, nor do you have the chance to actually bubble that in? You don't have a chance to bubble in the negative sign. So there's a quick factoring problem in terms of factoring trinomials or really quadratics in that sense, right? And that's also kind of how you break things down using open-ended strategies. So I do hope that, you know, it sort of filled in some gaps for you guys of making, one, the open-ended section a little bit more approachable, because I know it can be so intimidating at first, and two, just in turn tackling some of the concepts that you wanted to cover. Okay, let me minimize this. Let me go back. Post. Let me see here. Nope. Okay, so we're good. So we're good to go. I'm going to go back to the document that I was suggesting. Okay, so I'm going to go back to that document. And I'm going to start covering some of the problems with respect to ratios and proportions. And then in future classes, we will make sure to cover a lot of the parabolas, slope-intercept form concepts that you guys are asking for. Okay, so let's go here and here. Awesome. All right, so ratios and proportions. Here we are in a random sample of 200 cars of a particular model, 3 have a manufacturing defect. At this rate, that's your first kind of general hint. The moment that they say rate, you think ratio, rate, right, proportion. A rate, by the way, is when you have let's say, a specific, like unit over unit, like miles per hour. It's when you have so many cars per defects, right? So the words that you usually want to pay attention to if you have a rate, obviously the word rate, also the word per. Sometimes they'll throw the word for in, like for every, you know, for every sandwich you have 2 slices of bread, right? that's the idea, right? So you're kind of setting it up that way there's some sort of ratio. At this rate, how many of the 10,000 cars of the same model will have a manufacturing defect? Notice every single time, even though I'm so used to doing these questions, and I've worked with like hundreds of students over the year, probably like thousands at this point. Notice I still follow the same strategy. I still circle the thing that's being asked. I still interpret the problem for what it is. I still pay attention to the things that most commonly they need to do. And I do this intentionally so that way it sort of always keeps me grounded with how to approach the problem. So that way I can look at any problem and I feel confident enough on actual like test day to say, oh yeah, I've seen a style of this problem before. It may not be the exact same problem, obviously, but I've seen enough of these problems to feel confident enough in order how to approach it, okay? In a random sample of 200 cars of a particular model, 3 have manufacturing defects. So here's what we want to do. We have, let's say, 3 defects per 200 cars. Now notice what I'm doing. I'm lining up my units, okay? Equals, this is what makes this, right? At this rate, whenever I have 2 equal rates, we refer to that as a proportion. Just FYI, okay? Whenever I have a rate that is equal to another rate, and I'm setting this for like with an equal sign, that is what we refer to as a proportion. At this rate, which means they will follow the same, you know, ratio, how many of the 10,000 cars of the same model will have a manufacturing defect? Well, because of the fact that I'm trying to figure out defects, this becomes X defects or question mark defects, right? This is what I'm trying to solve for. And then because my cars here is on the bottom, I'm going to do 10,000 cars here. Now, what happens is if I'm trying to solve for X up top, I then want to cross multiply the 10,000 over to the other side. And basically, it's like multiplying by the reciprocal, right? I would multiply by the 10,000 cars to both sides. They would end up canceling, right? But I'm going to cross multiply up top here. I then end up getting 3, and I'm just going to put defects like this to make this easier, times 10,000 cars, okay, over 200 cars. Now, quick tip, this is actually in the non-calculator section. So as we're doing a lot of these problems, I'm going to show you non-calculator strategies. I'm also intentionally going to show you units, because the SAT loves using units as a strategy. Now, did I solve for the right thing? Yeah, because cars over cars will cancel, right? Units 101. Cars over cars will cancel. I'm left in units of defects. I then have 3 times 10,000. which will give me my 30,000 like this. Okay. And that's 30,000 defects, which I know is what I'm trying to solve for, but it's over 200. So pay attention. If I have 3,000 over 200, I can cancel out some of these zeros here like that, right? You can take, and then this becomes 300 divided by 2, which is 150 defects. So A is going to be my answer to this question. Okay. One of the things I would recommend to you guys, just because we're kind of coming up on that time. And once again, everything will be saved. We'll do the videos and everything for you, so that way it makes it easy and you have a chance to go back and watch it. But I would absolutely encourage you to, if you haven't yet in any sort of capacity, I would absolutely encourage you to log on to the Embrace Tutoring TV YouTube channel, which we can post a link for. And it's already in there. And then all the videos are there for you, right? Every single problem's already broken down. Everything's there for you, so that way you guys have it. And then you have a chance to sort of go at your own pace as well. Because remember, this class is for a multitude of students, so that way you guys can get the most out of it. But there are going to be areas that you are stronger in or weaker in, respectively, than other students. So you're going to want to spend a little bit more time in those specific sections, or a little less time in those specific sections than some other students. So there is going to be some, I would say, like asynchronous learning, where you're going to need to go and you're going to need to kind of work outside of class. And one of the better ways to do that and familiarize yourself with the test is by far to use the YouTube video and the library that we've created for you guys. So you guys can essentially use that. Okay. Do your best when you're participating in this class. Do your best to try to put your best foot forward. We're going to send everything out so that way you guys have it. It's been an honest pleasure, and I can't even see any of you, but if you have questions along the way, do not hesitate to reach out. Okay, we're here for you. We want to make sure that you guys are in a good position. Okay. On that note, I will send out your homework, but it is to complete SAT practice test 1. It's been an honest pleasure. If you need to get in touch with me with any reason or for any reason, just feel free to respond to the emails and the homework and announcements that I will send to you momentarily. All right, guys, take care. Have a great day. Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.